Welcome back. In the last couple of videos we have discussed acids and bases and their different definitions, and then the strength of acids and conjugate bases. And today we're going to start talking about pH. So you're probably familiar with the term pH. You've heard it used a lot. If you've got a swimming pool, you have to measure the pH, but not a lot of people actually know what pH is. So we're going to start talking today about what pH is and how to calculate it, and it's not super complicated, as long as you know how to use your calculator. So let's get into talking about what pH actually is. All right, so pH stands for potential of hydrogen. So it's about how much hydrogen ions there are, because again, we're talking about acids and bases, and acids are all about that hydrogen ion concentration. Bases are about hydroxide, but more hydroxide you have, the less hydrogen you have, and so therefore you're dealing with the potential of hydrogen ions. That's how it's denoted. And if you look at the Bronsted-Lowry definition, it's all about whether it's a proton acceptor or a proton donor, and so therefore we're dealing with hydrogen. So the pH scale is a logarithmic scale that shows the relative concentration of hydrogen ions in solution on a scale of 0 to 14. Now, what does this mean? If you know what a logarithm is, we're all good. If you don't know what a logarithm is, we're all still good, because this is not really using logarithms that way. But basically what a logarithm is just a fancy way of doing exponents. So we're dealing with a logarithm base 10. We're dealing with exponents of 10, and so that's basically all a logarithm is. But if you don't really understand logarithms, you don't have to worry about it all that much. You don't have to actually calculate anything complicated logarithm-wise. All you have to know is that it's more or less just a button on your calculator. But notice that we're talking about the relative concentration of hydrogen, and it's on a scale of 0 to 14, okay? Below 7 are acids. pH above 7 are bases. If it equals 7, then your pH is neutral. All right, so here's a picture of our pH scale, and you'll notice that 7 is not right in the middle, because this scale actually shows you farther to the left side. You actually can have a pH less than 0. So that 0 to 14 scale is just kind of the standard normal, but it is possible to have something that is less than 0 and greater than 14. That is possible. And we call those super acids and super bases if their pHs are that low or high. But you'll notice that a pure water is neutral, and neutral substances have a pH of 7. So this is our pH scale. All right, so pH is calculated from the concentration of your hydrogen ions, or hydronium, because remember, a hydronium is what happens whenever water self-ionizes, gets that H3O+, and conceptually hydronium and hydrogen ions are conceptually equal. So if I say hydrogen ions or hydronium ions, it means the same thing as far as we're talking about this. So the way that you calculate pH is actually pretty simple. Your pH is equal to the negative logarithm of your H+ concentration. So I want you to notice the brackets. Those square brackets around something are a way that we show we're talking about concentration. Instead of writing out the word concentration of H+, that's a little cumbersome. So instead of writing out the word concentration, we use the brackets around the symbol to tell us we're talking about the concentration, specifically the molarity. So this is your pH is the negative logarithm of your hydrogen ion molarity. That's what this formula means. Now, sometimes you're given the concentration of hydrogen and you need to find the pH. Sometimes you're told the pH, but you need to know the concentration of hydrogen. And like I said, a logarithm is just a fancy special way of doing exponents. So the opposite of the logarithm is basically just 10 to an exponent. So if we want to find the hydrogen ion concentration, the brackets around the H+, we want to find the hydrogen ion concentration, that's going to equal 10 raised to the negative pH. So it's a negative logarithmic scale. So pH is the negative log of your hydrogen ion concentration, and your hydrogen ion concentration is 10 to the negative pH. Those negatives are very important, so make sure you don't forget them. So let's look at an example of solving one of these. So we have a solution containing 6.8 times 10 to the 7th moles of H plus ions. So that's moles per liter of H plus ions. So what that tells me is my H plus concentration is 6.8 times 10 to the negative 7th moles per liter, or you could do it as molarity. And the question wants to know, is it an acid or a base? So to do that, I need to know its pH, and I need to know whether it's above 7 or below 7. So the pH is going to be the negative logarithm of your H plus concentration. And so we simply plug in our numbers. We have a negative log of 6.8 times 10 to the negative 7th. And that plugged into our calculator gives us an answer of 6.2. Now pH doesn't really have a unit, so our pH is just 6.2 without a unit. That is less than 7, and so therefore this is an acid. So the question wanted to know, is it an acid or a base or a neutral? We have to find the pH in order to know whether it's an acid, a base, or neutral. So let's look at another example. A solution contains 8.3 times 10 to the negative 11th moles of H3O. So this time I have my concentration of hydronium ions is 8.30 times 10 to the negative 11th moles per liter, or molar. Is this solution acid, base, or neutral? So again, we need to find our pH. Well, pH is the negative logarithm of our H plus concentration. But I wasn't given the H plus concentration. I was given H3O plus. But again, these are conceptually the same thing. So if I have my hydronium concentration, that's the same as giving you the H plus concentration. So that means our pH is the negative log of 8.30 times 10 to the negative 11th. And so I plug this into my calculator and I get an answer of pH is equal to 10.1. Well, that pH is greater than 7. So when the question says, is it an acid, a base, or neutral? Well, greater than 7 means this is a base. All right. So let's do one more example of a pH type calculation. So I have a basic solution. This time I'm telling you it's an acid or a base. It's basic. I have a basic solution whose pH is 11.6. I want to find the concentration of hydronium ions. I want to know what H3O plus is. Well, H3O plus is the same as H plus, and so we know that the hydrogen ion concentration is equal to 10 raised to the negative pH. So that means my hydronium concentration is equal to 10 raised to the negative 11.6. So I plug this into my calculator and I get an answer of my hydronium ion concentration is equal to 2.51 times 10 to the negative 12th, and it's a concentration, so my unit is molar. And there we go. That is how we solve for the pH and the concentration. A couple of examples of those. So now let's talk about water for a minute. Since most of these solutions are always going to be in a water solvent, and so water is the solvent, we're aqueous solutions, so we need to deal with water and the pH of water for a little bit. So remember, water is amphoteric, which means it can act as both an acid and a base. And if we think about water as H2O, instead of H2O, we think about it as HOH, then when it self-ionizes, it separates into H plus ions and OH minus ions. And so for every water molecule that separates, you're going to get one hydrogen and one hydroxide. Your numbers of hydroxide and hydrogen ions will always be equal because of the way that the water molecule works. So to represent that self-ionization, we use something called the ion product constant of water, Kw. Now I want you to look at that. It's an ion product. Well, in math, a product is what you get when you multiply two things together. And we're dealing with hydrogen ions and hydroxide ions. So the ion product has to do with the concentrations of both of those multiplied together. And that's what Kw is. Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. You just take the two concentrations, multiply them together, and you get your ion product constant. Now, pure water is neutral, which means its pH is 7.0. So if we were to calculate the hydrogen concentration from a pH of 7, we get a hydrogen ion concentration of 1 times 10 to the negative 7th moles per liter. So 1 times 10 to the negative 7th is our hydrogen ion concentration. And as we just said, it's a neutral solution, so that means the hydrogen ions and the hydroxide ions have to be completely equal amounts. So that means the concentration of your hydroxide is equal to the concentration of your hydrogen. So that means your hydroxide ion concentration is also 1 times 10 to the negative 7th. So if we want to find our Kw for water, we're going to take our hydrogen ion concentration and multiply it by our hydroxide ion concentration, 1 times 10 to the negative 7th times 1 times 10 to the negative 7th, and that gives us an answer of 1 times 10 to the negative 14. So what you'll notice is that this is the ion constant for pure water. Well, pure water is always going to have equal amounts of hydrogen and equal amounts of hydroxide, and so this will always be the value for Kw. This is the ion constant of water. This is a constant that we're going to use always. So 1 times 10 to the negative 14th is our ion constant for water. So let's look at an example in which we would use that. The H plus concentration of a solution, so I've got my hydrogen ion concentration is 3.2 times 10 to the negative 4th molar. Okay? The question wants to know what is the hydroxide ion concentration. So I want to know what is my OH minus concentration. Well, I know that Kw is 1 times 10 to the negative 14th. That's always the answer. That's always the value for Kw. So I know that Kw is equal to my H plus concentration times my OH minus concentration. So if I'm looking for OH minus, all I have to do is divide both sides by my hydrogen concentration. So that it cancels out over here. And so that would mean that my hydroxide ion concentration is equal to Kw divided by my hydrogen ion concentration. Well, Kw is 1 times 10 to the negative 14, and my hydroxide or hydrogen concentration is 3.2 times 10 to the negative 4th. So now I simply plug this into my calculator to get an answer of my hydroxide ion concentration of equal to 3.1 times 10 to the negative 11th molar. And it is a concentration, so it is coming out to be in molarity. Okay? So this is using our Kw to find the other concentration. So let's look at another example of that. The OH concentration this time, now I have my OH minus concentration, is 9.60 times 10 to the negative 10th molar. Question wants to know what is the hydrogen ion concentration. Well, we're still going to have to know that Kw is 1 times 10 to the negative 14, and Kw is still the H plus concentration times your OH minus concentration. And so now I'm going to, again, solve my equation for what I'm looking for. So I'm going to divide both sides by OH this time, because I'm looking for H plus. And so I get an answer where my H plus concentration is equal to Kw divided by my hydroxide ion concentration. So 1 times 10 to the negative 14 divided by 9.60 times 10 to the negative 10. And I plug this all into my calculator and I get an answer of 1.04 times 10 to the negative 5th molar. All right, so that is using the ion constant of water to help us find the concentrations of hydrogen and hydroxide. So if we're dealing with hydrogen, we're usually going to be talking about pH. If we're dealing with hydroxide though, then we're going to have to deal with something else. So just like with pH, we can use the concentration of hydroxide to find the potential of hydroxide. We call that pOH. So pH and pOH are very much related, right? In fact, the equation is exactly the same. Your pOH is the negative log of your hydroxide ion concentration. See how pH was the negative log of your hydrogen concentration, so the pOH is the negative log of your hydroxide ion concentration. And so you can also flip that around and say your hydrogen ion concentration is equal to 10 raised to the negative pOH. So they're kind of exact opposites, right? And so we can set up a scale based on the pOH. We have a pOH scale. And now the pOH scale is exactly the opposite of your pH scale. So if you look at this diagram, you have the top part of it has your pH and the bottom part has the pOH. And you'll notice that the pOH on the acid side, notice the red side is acids and the blue side are bases. The acids have a pOH of 14 and bases have a pOH of 0. Whereas the pH scale, acids are 0 and bases are 14. They're exact opposites. So a high pH means a base, a high pOH means an acid. They're opposites. It's very important that you understand that. But if you look at this scale a little bit more closely, if you compare the pH and the pOH of the same solution, so let's say something with a pH of 5. If you look at the pH of 5, the pOH is 9. So 5 plus 9 is 14. Okay, so you look at the pH of 10. Well, when you have a pH of 10, your pOH is 4. 10 plus 4 is 14. You'll notice that for every single solution, every point on the scale, your pH plus your pOH is always going to equal 14. That's a very important equation to remember. pH plus pOH equals 14. That will always be the case. So if you know your hydrogen ion concentration or your hydroxide ion concentration, you can always find the other one in multiple ways. You can do it by finding your pH, subtracting from 14 to get your OH, your pOH, and then you can find your OH concentration that way. You could use the kWs to do it. There's lots of different ways that you can do it. You're going to get the same answer regardless of which way you do it. So it doesn't really matter the path that you take. It just matters that you get the right answer. So let's look at an example here. We have a solution that contains 6.80 times 10 to the negative 7th moles per liter of hydroxide ions. So my hydroxide ion concentration, that's a minus, is equal to 6.8 times 10 to the negative 7th molar. What is the pOH? Well, pOH is going to be a negative log of my hydroxide ion concentration. So 6.8 times 10 to the negative 7th. And so my pOH is equal to 6.17. That's the first answer there. That's my pOH is 6.17. Is this solution acid or a base? Now, a lot of you are going to look at this and say, well, that's an acid. It's less than 7. If it was pH, you would be correct. But on pOH, less than 7 is a base. So this is actually a base because pOH is opposite of pH. The next question, so what is the hydrogen ion concentration? Okay, so there's multiple ways we could do this. We could use our Kw equation. Kw equals the hydrogen ion concentration times our hydroxide ion concentration. and you could solve for your hydrogen ion concentration that way. Or you could use your pH plus pOH equals 14, and we could solve for our pH and then use our pH to solve for our hydrogen ion concentration. That would take us 2 steps. So it's mathematically maybe a little bit easier, but it takes more steps. So I'm actually going to use kW to figure this out. So I know that my kW divided by my hydrogen or my hydroxide concentration is going to give me my hydrogen concentration. So I plug in my numbers. 1.0 times 10 to the negative 14th is kW, divided by my hydroxide concentration, and that gives me an answer of 1.47 times 10 to the negative 8th molar. So that is my H plus concentration. I'm going to go ahead and write it over here. So my H plus concentration is 1.47 times 10 to the negative 8th molar. Okay? So what is the pH? Now, there's 2 ways that I could do this. I can either take my H plus concentration that I just got. I'm going to go ahead and erase this here. Take my H plus concentration that I just got, and I can do that my pH is the negative logarithm of my H plus concentration. Or, and when I do that, I would get an answer with my pH equaling 7.83. Or I could do that, plug in the calculator. Or then again, we have pH plus pOH equals 14. So that means my pH is going to be 14 minus my pOH, which would be 14 minus 6.17, which comes out to be 7.83. So regardless of which of these 2 methods I use, I get the same answer of 7.83 for my pH. So again, there's more than one way to solve these problems if you look at the connections between all of the different equations. So that's a very quick and dirty basic way of examples of showing how to do pH calculations. Again, it's not really complicated. You just have to use the calculator correctly and know which equation you're using when you plug it in. I hope you don't struggle too difficult with calculating pH, and just read the questions and make sure you understand how to use your calculator. Thanks for watching, and have a day.